This is a video walkthrough of solving for an unknown number 5. We have a set of simultaneous equations here. One's from the horizontal direction, one's from the vertical direction. They involve the normal force, F sub n, and the frictional force, F sub r. Two equations and two unknowns. Solve for both the normal force and the frictional force. There are a couple of ways to do this. We're going to do both. The pure mathematicians like to leave expressions until the very end. So they will leave sine and cosine in the equation until the very end. They get one last expression, and then they plug the numbers in. Physicists like to plug numbers in as soon as they can because it makes the equations simpler. Let's start by leaving them in. So we're going to look at the top equation. F sub n sine 10 degrees plus Fr cosine 10 degrees is 5,993 newtons. And we're going to solve this expression for F sub n. We start by subtracting the frictional force cosine 10 from both sides of the equation like that. This leaves that expression, and now we can just divide by sine 10 degrees, divide both sides by 10 degrees to isolate F sub n. So we do this, and now we get just F sub n on the left-hand side. And that's our goal. So now we can take this expression for F sub n, which we got from the top equation, and substitute it in for Fn into the bottom equation. So here's the bottom equation, different equation, repeated for convenience. And we're going to substitute what we got for F sub n from the top equation into the bottom equation right here for Fn. There it is. There's the square bracket. This is F sub n from the top equation. There's F sub n from the bottom equation, and here is a substitution. This is the bottom equation with the expression from the top equation for F sub n substituted in. So now we have one equation and one unknown. We have to do a lot of algebra to isolate the F sub r. So the first step is to get the cosine 10 degrees through, distribute that cosine 10 degrees. So one term is, the first term is 5,993 newtons times cosine 10 degrees divided by sine 10 degrees. And there it is. The second term on the left-hand side is minus the frictional force, cosine 10 degrees divided by sine 10 degrees. And here it is, cosine squared 10 degrees divided by sine 10 degrees times F sub r, the frictional force. And the right-hand side is unchanged. So now we're going to solve for F sub n, F sub friction. We can add cosine squared 10 degrees divided by sine 10 degrees, Fr to both sides. These two terms will sum to 0. We're collecting the Fr on the right-hand side. So now we have this, and we can subtract 15,000 newtons from both sides, continuing to try to isolate the frictional force. And now we have this. We're getting close. We can factor out the frictional force on the right-hand side from these two terms, and we get this. We just took the frictional force out. Now we want to get the frictional force by itself, so we just divide both sides by this thing in square brackets. That eliminates the term on the right-hand side, so we have just the frictional force. So the frictional force is this, which is this divided by that. Now, finally, we can substitute in for cosine 10 degrees and sine 10 degrees. Sine 10 degrees is 0.1736. Cosine 10 degrees is 0.9848. And we substitute it in here. Punch the numbers on the calculator. We get 33,990 minus 15,000, which is 18,990 newtons in the top. Punching the buttons here gives us 5.585 plus 0.1736. And that's 5.759. And that gives us a frictional force of 3,330 newtons, rounded to two significant digits. We have to get Fn, but we have an expression for Fn already from the top equation. And all we do is substitute in Fr, which we just got. And I didn't round off when I substituted in here. And that's 15,800 newtons. And that's the right answer. Let's do it a different way, by plugging in the values for sine 10 and cosine 10 immediately. So there's our expression for Fn, and we're not going to carry around the cosine 10 and sine 10. We're going to plug in for them. So this is just a number. This is just the coefficient of the Fr. So our Fn is just that. we can substitute that expression into the bottom expression for Fn, and we get this. So there's the expression for Fn. And then we substitute in for sine and cosine. We're not going to carry those around. We multiply this through on the left-hand side. And we get this. And now we collect the FR terms, adding 5.585 FR to both sides. Then we subtract 15,000 newtons from both sides. And then we divide by 5.759 both sides. And that gives us FR. And this is exactly the same expression we got before. It is 3,300 newtons. And of course, Fn is the same. It's a lot of math, but science has a lot of math. You have to deal with it.